The Greenland Ice Sheet. The Greenland Ice Sheet is the second largest body of ice in the world, only surpassed by the Antarctic ice sheet. Around 3 million km3 worth of ice is stored in the ice sheet, which is a substantial part of the planet's total mass of freshwater. Melting of the ice sheet is a major contributor to global sea level rise and may alter ocean currents and climate patterns. Monitoring the mass balance of the ice sheet to gain a better understanding of these dynamics. Mass gain _ mass lose equals mass balance. What is mass gain? The ice sheet loses mass in many ways, but only one phenomenon adds to it. Precipitation. Moisture in the atmosphere condenses to create precipitation as snow or rain. Both add to the mass of the ice sheet. Some of the rainwater might run off, but a fair amount freezes within the upper snow layer and stays there. Similarly, some snow might melt in summer, but will refreeze when conditions get cold again. What is mass loss? Up until the 1990s, mass loss more or less leveled out mass gain so that the ice sheet had a somewhat constant mass. Since then, mass loss dynamics have regularly outweighed mass gain, making the ice sheet shrink. Number 1 Surface melt. Number 2 Basil melt. Number 3 Evaporation and sublimation. Number 4 Calving. Number 1 Surface melt. In summer, the ice sheet is exposed to higher temperatures and stronger radiation from the sun. This melts the snow and ice at the surface, especially at the edges in the lower elevations. Some will refreeze and remain part of the ice sheet, but each year a significant amount will escape through melt rivers and flow into lakes or the sea. This meltwater contributes to sea level rise. Number 2 Basil melt. Not only does the ice melt from the surface, which is exposed to the sun, it also melts from the lower and inner surfaces, called basal melt. At the bottom, the friction of the ice moving across the surface plus weak geothermal heat emitting from inside the earth causes melting. Meltwater running within the ice creates melting as well, as the water is warmer than the surrounding ice. This meltwater contributes to sea level rise. Number 3 Evaporation and sublimation. Mass leaving the ice sheet as vapor either from meltwater, evaporation, or by phase shifting directly from the snow or ice phase, a process called sublimation. Number 4 Calving. Part of the ice sheet stretches into the ocean where the glacier fronts become unstable and start to break off into icebergs, a process called calving. How much mass is lost from the ice sheet in this way is hugely dependent on the velocity of the ice flow from the center of the ice towards the margins. In most circumstances, a fast flow will cause more ice to calve from the fronts. Ice flow. Ice flows from the high interior to the margin of the Greenland ice sheet where it either melts or is lost to iceberg calving. Ice flows faster in a warmer climate because meltwater originating from the surface reduces friction at the bottom of the ice sheet. Increased iceberg calving from outlet glaciers, often termed the ice dynamic mass loss, is responsible for a substantial part of the mass loss of the Greenland ice sheet. Darkening ice. Solar radiation, sunlight, is the main provider of energy for the melting of snow and ice in Greenland. As the solar radiation reaches the ice sheet, a large percentage is reflected back up. Fresh snow reflects up to 90% of sunlight. The ice reflectivity, aka albedo, therefore exhibits a strong control on the melting of the ice sheet. However, Greenland ice albedo has been decreasing since the beginning of satellite observations in 1981. Thinning ice. The thickness of the Greenland ice sheet fluctuates with climate. The ice sheet grows and becomes thicker during relatively cool climatic conditions and shrinks and becomes thinner during relatively warm climatic conditions. The thickness of the ice sheet is influenced not only by the difference between snowfall and melt at the ice sheet surface, which the PROMIS network continuously observes, but also by the dynamics of flowing ice within the ice sheet. Retreating ice. The margin of the Greenland ice sheet moves back and forth depending on the climate. During cold times, like the ice ages, the ice margin advances and covers the land and may even form ice shelves extending into the ocean. In a warming climate, the ice margin retreats, revealing freshly exposed land, which is darker than the ice, therefore absorbing more heat from the sun. Meltwater. The quantity of meltwater is not directly affecting the mass balance but is rather a product of it. However, it is still of interest to promise, since it can possibly alter the ocean dynamics around Greenland. Furthermore, it's an important energy source in Greenland, providing hydropower to remote societies. For instance, the Watson River at Kangerlussuaq, southwest Greenland, has been monitored by pressure transducers at the local bridge since 2006. The Watson River drains an ice sheet area of about 12,000 square kilometers, Lineback et al., 2015, and a 590 square kilometers proglacial area, has Holt et al., 2013. During the peak of the melt season, large amounts of water and sediment are transported by the river, but during the cold season the river falls dry.